Thank you, Bharti. Bharti, am I audible?
Yes, ma'am. You're audible, ma'am.
Good morning, respected Vice Chancellor, sir. Uh, Good morning, Dr. Kunal Roy, our keynote speaker, Dr. Professor A.K. Tiwari, Professor Nirmal Singh, Professor Gurpreet Kaur, dear colleagues and promising young pharmacists, on behalf of the Department of Pharmaceutical Sciences and Drug Research and the organizing committee, it is my pleasure and privilege to propose the vote of thanks to all who have made and are making these series of workshops possible and successful. It is said that well begun is half done, and we could not have asked for a better beginning to this 3 day workshop than an inspiring inaugural talk by our Vice Chancellor, sir, though there were some hiccups. But thank you so much, sir, for your insightful and motivating inaugural address. Your thought provoking
Several awards, including the AICTE Career Award 2003-4, DST Fast Track Scheme for Young Scientists 2005, Bioorganic and Medicinal Chemistry Most Cited Papers of 2003 to 6, 4 to 7, 6 to 9, and various awards from elsewhere. The Netherlands Bioorganic and Medicinal Chemistry letters, he has most cited papers in many of the journals and has received award from elsewhere too. He has been ranked in top 2% science wide author database of the world, and he has been ranked at 87 in the subfield of medicinal and biomolecular chemistry. If I'll speak about him, it will take so much of time. So, ending here, I will request Dr. Roy to for his inaugural and for his keynote address.
Thank you, Vati. Am I audible?
Yes, sir, you are audible, sir.
Thank you. Very good morning to everyone. At the outset, I would like to thank Dr. Arvind, Vice Chancellor, Punjab University, and Dr. Om Silakari, Associate Professor of Department of Pharmaceutical Sciences, for giving me this opportunity to speak on this platform. So today, I will now share screen. I hope you are able to see my screen. And my today's topic is a new similarity-based read-across algorithm for the prediction of small datasets, case studies with nanotoxicity data. Usually, I speak on the topic of quantitative structure-activity relationship, or QSR, but today I have chosen the topic of read-across, which is a similarity-based algorithm for prediction purpose. And the examples or case studies that I discuss here are related to nanotoxicity. I have not selected any datasets that is related to natural products here, but the techniques that I discuss here can be used for screening natural product-based compounds also. So this work was done in collaboration with the University of Danzig. Okay, first I'll go to some introduction on nanomaterials. As all of us know, that nanoparticles are a very important class of materials, and they have very interesting properties, which is due to their high surface area to volume ratio. And due to this, they have high reactivity, and they have specific physiochemical properties, which entitle them for use in different spheres. They are used in different industries, including pharmaceutical industries. They are used in chemical industries, food processing industries, textile industries, ceramic industries, and solar cell industries, and so on. And due to their widespread use, humans are exposed to these nanoparticles. And not only humans, different species of the ecosystem are also exposed And as the lower level organisms in the ecosystems are exposed to nanoparticles, so any toxicity due to nanoparticles will actually come through the food web to the humans also. So we need to study the effects of toxic effects of nanoparticles on the lower level of organisms also. As I mentioned that nanoparticles are nowadays used in different spheres, in different industries. So we also see their adverse effects on different levels of organisms. As they have very small particle size, they can pass through the cell membrane and they can be accumulated within cells, exhibiting toxicity. And it has been shown that the toxicity exhibited by nanoparticles may be due to membrane damage, release of toxic ions impairing enzyme action, and through reactive oxygen species generation. So we need to understand the toxicity of nanoparticles on environmental health and human health, and we should generate sufficient data on their toxicity profile so that we can assess them, we can assess their risk. And in silico methods are very important to understand toxicity of chemicals in general and specifically for nanoparticles, which we are discussing here. And such in silico toxicity prediction is acceptable by different regulatory agencies like USEPA and legislation like REACH regulation in the European Union. Among nanoparticles, there are two major groups. One is carbon-based nanoparticles, and another major group is metal oxide nanoparticles. Due to their interesting properties, metal oxide nanoparticles are used in textiles, paints. They are used as water treatment agents. They're used in solar batteries and as automobile catalytic converter. So the humans to nanoparticles through this one of these sources. For example, say nanoparticles are used as UV filter in cosmetics, so the human skin is directly exposed to nanoparticles. And these nanosized particles show toxicity to some organisms. And humans, they can cause respiratory, cardiovascular, and inflammatory disorders. And toxicity data for nanoparticles are available to only limited extent. We have only limited number of experimental data available for toxicity of nanoparticles. So we need to fill the data gaps and uncertainties of metal oxide nanoparticles for their toxicity, which have obstructed their potential risk assessment, and it has doubted adequate regulations. So we need to bridge data gaps, and for these, we need to use some alternative methods of evaluation of risk of nanoparticles. Among alternative methods, the one of the prominent method is in silico methods, which can give us data for untested chemical, here specifically for nanoparticles. And we can generate even before we have the chemicals physically. Now regarding metal oxide nanoparticles, this slide shows the proposed mechanism of cytotoxicity in E. coli cells. And the proposed mechanism includes disruption of electron transport chain, membrane damage, release of free electrons, causing generation of reactive oxygen species, and through oxidative stress, they can damage nucleic acid and proteins, which can lead to apoptosis. So these are roughly different mechanisms of action of toxicity of metal oxides.